Hey, this is Dr. Williamson again. This is the other part of how to graph data. This is that large data set that's going to do the non-linear. I've already 10 keyed it in rather than making you guys watch me do all that. So it's a whole bunch of data points. Oh, I need to center all of that. It's not quite all centered. So let's do that. And these all need to be, let's see here, 2 decimal places because that's how it was originally. Let's see here. Ooh, that's too many. Okay. So it was given to us as 2 decimal places. Okay, so let me kind of fix that. Some of it's not 2 decimal places. So, okay, that's too many now. And go back. All right, that looks correct. So now what I want to do is I want to plot this. So I'm going to go to Insert, Charts, Scatter, and I get this thing. Okay, now I'm going to enlarge it so I can see what I'm doing. Now I'm going to add axes labels, axes title. This axis title is going to be pH. And let me make it larger. Well, let's make that, let's say 16 bold. This axis title will be volume of NaOH added, and that's in milliliters. Let's put that in 16 bold. Title is going to be, oops, chart title. Titration of, this happened to be acetic acid with I think it was 0.1 molar 0.1 molar sodium hydroxide with 0.100 molar sodium hydroxide. Okay, let me make sure I have the concentration right. Yep, molar sodium hydroxide. Now, I've got too much space down here. I don't really need all that space down here. There's not a scientific reason for it. And I really need this to be expanded as much as possible to get the end point of the titration. And this 14, I don't need all this space right here either. So I'm going to change this to be 2 to, let's say, 13. Maybe not so well. Okay, I can do 2 to 13, but I don't want the major unit to be 3. Maybe I can make the major unit be 1. But that expands that much better for me to be able to get the endpoint better. Also, I want to expand it out this way because right in here is the end point, and I want to be able to draw my best fit curve in there as good as possible. It means I want to expand this as much as possible. So I don't necessarily want to go to 30. I might want to go to, say, 28, which is really nice because I can go here, 28, take a look and see what happens. That looks okay. Oh, wait a minute here. Let's make this larger than, let's see, those were 16. So maybe I'll make that 18 and bold, right? Make these guys bigger. Home. Maybe make those 12. Bold. Home. 12. Bold. Right? That looks pretty good. At this point, this would probably be a good time to save it. Let's pretend I saved it. I'm now going to copy this, go to Microsoft Word, File, New blank document, right? Layout, margins, 0.5, orientation, landscape, home, paste. And then I'm going to zoom out a little bit so I can kind of see better. Right? You guys see that? And I'm going to grab the corner of this and drag it out as big as I can. And the bigger that is, that makes estimating the equivalence point even better. And the better I could do that, the more accurate I could get it. Maybe, the better my scientific discovery is. Let's see here if I can go to wrap text and go to, no, it's not letting me do that. Okay, well, that might be as good as I can expect for this now. Okay. And that's what I would do for my assignment. No, it's too much. Okay, guys? Guys get the idea? And the bigger it is and the more expanded it is, I'm going to go in by hand and try and gently sketch in and fill in the best fit curve. And then I could figure out about where the inflection point is. And then I could figure out the equivalence point. Later, I'll show you guys how to do a first derivative plot, which will really let you get it nice and accurate. Okay, then I hope this helps. Later, I'll do a first derivative plot for you guys. Okay, then. Bye.